In this video, I'm going to run through about the first half of the slides on Boolean logic and conditional execution. I'll begin by reviewing some of the topic of functions, which we covered in earlier videos and earlier slides. Talk about the execution of statements, the flow of execution in our programs, in our code. Mention the modulus operator. So this is kind of a mathematical operator, often used to test the truth or falseness of given expressions. And then we'll talk about Boolean expressions more broadly. These are expressions that can be reduced to a value of true or a value of false. We'll see how those work with logical operators too. In the next video, I'll get into conditional execution, a way to structure your code so that certain statements either are or are not executed depending on Boolean values, true or false. So one of the exercises we looked at last time was to write a script containing a function that would calculate the area of a circle if we gave it as an argument the value of the radius of that circle. We kind of begin that script with a few lines describing what the script will need, what our program needs, and what will be returned by it, the area of the circle. First line here is to import the math library. We see that being used to get a kind of an accurate, precise value of pi for area calculation. Then finally in these lines, our circle underscore area function is defined. It takes one parameter called r. Within that function definition, so on a lower line, indented one space, we see a variable called area is assigned a value equal to the constant pi from the math library times the value of that r parameter to the power of 2. Finally, that value of the variable area is what's returned by the function. So then, those three lines define the function called circle area. Lower in the script, below that in the script, would be the function call. Here we see circle underscore area is called with an argument of 1.0 for the r parameter here. And the output of that function, the value of area that is returned, is going to be then printed. And then finally there's a very similar function call that passes an argument of 2.0. So in the flow of execution here, math is imported, a function is defined, but the first statement that gets executed here is the call of the circle area function, which then is informed by the lines of code we use to define that function. After an answer is given here, it'll be equal to pi. That value is printed. Next, the interpreter will go to the last line. So this circle underscore area function is called again. These statements are referenced, passing an argument of 2.0. So 2.0 to the power of 2 will be 4. So the value of area in this function call will be a value of 4 times pi, and that's what's going to get printed to the console. Jumping now to Boolean expressions. Boolean expressions make use of relational operators. You might hear me say Boolean operators. Other people might call them comparison operators. So remember, expressions are sequences of operands, think of them as just any values, that are related to one another using operators. And some of the operators we learned earlier were just the plus sign, minus sign, the asterisk for multiplication. So some sort of operation is going on. And when you multiply two numbers, the output is a number. When we use these relational operators to relate two operands, two values, the output for that is going to be true or false, in the sense that the expression either is or is not correct. So Boolean expressions that make use of relational operators yield true or false for Boolean values in Python. You can see a list of 6 of them here. Equal to, actually 2 equal signs together. It's kind of the relational operator. Exclamation mark, equal sign, that means not equal to. Greater than equal, less than or equal. It may, first of all, on this slide, it may be helpful to think of these as questions. Because the Boolean expression can be evaluated to a single value, true or false, you're really asking, are the values of x and y, are they equal to one another? Question mark. And if the answer is yes, then the value will be reduced to true. If the answer is no, it will be reduced to false. And then second, really emphasized on this slide, the single equal sign in Python, you'll remember, is an assignment operator. Double equal sign, 2 equal signs together, is the relational operator. So a single equal sign just means take what's on the right, whether it's an expression, a value that comes out of evaluating that, what have you, and assign it to the variable name on the left. The double equal sign is asking a question. Is x equal to y? Another bit of a review, the modulus operator. So this is one of the mathematical operators we learned about when we first covered expressions. So it's essentially asking, what's the remainder? Not asking how many times the right number goes into the left, but asking, well, if you are able to put the right number into the left x number of times, but not x plus 1, then then what's the value that's left? What's the remainder? So for 7 modulus 3, it would be 1. For 7 modulus 2, it would also be 1. You can put 2 into 7 3 times, and then you would have a remainder of 1. For 7 modulus 5, you'd have a value of 2. You can put 5 into 7 one time, have a remainder of 2. So this modulus operator is maybe more useful in programming, especially with respect to this conditional execution, than it is in kind of, I don't know, algebra or mathematics more broadly, at least as much as we learn, kind of in the typical curriculum. Here it's paired in an expression with a relational operator, asking, is the remainder from x modulus y equal to 0? And that's asking the question, is x divisible by y? Because if it is divisible by y, there will be no remainder. Another way to use it, along with a relational operator, is to test if x is an odd or even number. So any number modulus 2, if it's an odd number, it will have an output of 1. If it's an even number, we'll have an output of 0. So if x is even, that statement will output true. If x is even, output false if x is odd. And then here the third example, to get the rightmost digit of an integer, a base 10. Other concepts in Python and programming that make use of the Boolean values true and false, they make use of those values in a way that isn't kind of the basic correct or incorrect. So we learned about kind of the relational operators, the double equal sign, the greater than, the less than. Those can be evaluated and the output is either true or false based on whether or not it's correct. So here's some examples using the built-in bool function. The bool 4 equals 5, it's false because those are not the same number. Bool 4 greater than 3, that is true. Now truthy and falsy don't really make sense in the same correct-incorrect framing. But you can use the built-in bool function to evaluate the Boolean value of the number 4. Well, that doesn't really make sense. Is 4 correct? Is 4 incorrect? Don't know. But if you run the function, you'll get an output value of true. If you were to run it with a value of 0, you get a value of false. If you're using numbers, the Boolean value of any non-zero number is going to be true. The Boolean value of 0 is going to be false. If you input a string, so a sequence of characters into the built-in function bool, like we do here, doesn't matter what it says, if there are any characters there, the value will be true. If you input an empty string, no characters at all, the Boolean value is false. So in this sense, something that's called truthy or falsy, and those aren't kind of things that you'll see pop up in the Python shell. They're terms that we use to talk about the Boolean value of a value. They refer more to whether or not something is there. Think of it as kind of materiality. So a number of 0, it's not measuring anything, it's nothing. And so the Boolean value is false. But if you have any kind of number that could measure something, the value would be true. When we input a string, if the string is completely empty, just like a number 0, think of it as nothing there. It doesn't matter what the characters are. They could be false, false. As long as there are characters in the string, the Boolean value of that string will be true. Next, I'll mention logical operators. So these are other operators commonly used in building Boolean expressions. So 3 logical operators here: and, or, not. Basic tools across all of computer science and GIS as well, especially maybe the analysis of raster spatial data. They're slightly different than their everyday definitions. And here I'm contrasting the use of these logical operators in programming and in spatial analysis with the kind of everyday English language definition. So these operators, they kind of dictate how values, operands, relate to one another. They can be reduced in a Boolean expression to those Boolean values of true or false. Now, and, in order for an expression that makes use of the and operation to be true, both of the operands needs to be true. If or is used as an operator, only one, operand must be true. Both can be true, but as long as one is, that's fine, and it means the output would also be true. Not, this operator negates an expression, so it returns the logical opposite. So let's see those in action. So these expressions, whether they're making use of the kind of incorrect, correct, true and false, or the truthy, falsy, they act on two values here. So if you have true and false, the output will be false, because both are not true. If you use the OR operator and your operands are true or false, the result is true, because only one of them must be true. You say not false, well then the output is true. Not true, the output is false. Those might be a little bit easier to understand. So here on the right are some examples with variable names. So x equals true, y equals false. Z equals x and y, z will be false. Z equals x or y, z will be true. If z is not x and x is true, z will be false. Here are some graphics showing, I guess the Venn diagrams here, showing how the logical operators are working on these kind of, concepts here. Here at the top row, there's travel, tourism, and we see what is the output of travel and tourism. It's where they intersect. So think of and as intersect, or as union, travel or tourism. Only one of those must be true, but both can be. Travel not tourism, get an output such as this. Now here on the bottom row, we see when we have three different operators and three different operands, and two operators. And you'll note that there are kind of small parentheses around travel, tourism. But travel or tourism and web, the first expression here, using or, looks to travel or tourism. And so you can imagine an output like this, but then and is used to intersect this kind of totally blue top with whatever's in web. So what do you get as an output? Those three regions. Travel and tourism, not tourists. We start with the travel and tourism expression. So you can picture, after just reading that expression, this middle intersecting area would be blue, but then evaluating the expression using not tourists, that bottom region of the intersection is no longer blue. So I mentioned how this comes into GIS work, often through raster data analysis, kind of Boolean combining of data. So here we might have kind of different categorical areas, whether as vector polygon, converted to raster. I think raster is common because for each grid cell on kind of registered data layers, you can ask the question once for a grid cell that might be shared between layers and can be related to one another. So this kind of, just the way these three polygons meet suggests to me it's kind of categorical land use maybe data. Some sort of a singular feature here. So just two colors, presence, non-presence. And then here, these kind of suggest to me kind of contour lines, elevation. So these can be converted to raster from vector, and then kind of thresholded themselves. So here we've, in each one of these layers, just two different colors, and they can be related to one another using the OR output. So here, in either one of those inputs is the same grid cell of dark color, and if true, becomes dark color in the output. using the AND operator, kind of an intersect, the question is a grid cell darker in both of the inputs? And so you get kind of a smaller extent of that dark color in the output. So here's how that might look just in lines of code. Kind of if area has a value, you have some suitability value. So x equals area greater than 150 and suitability greater than 0.8. X is true. And so this question could be asked for every grid cell, say, in the image.